Hi everyone! In today's tutorial, we are going to study about pivot tables using Pandas. It's a very cool concept where you can aggregate data but in a matrix form. So let's understand with the help of a code. So let me firstly import my library over here, and here is my dataset. And this is what my dataset looks like. It contains order information about various customers from various states and regions. It contains about what kind of product they have bought, so that's their product name, what was the product category, and what was the sales, quantity and profit on that particular order. So let's understand pivot tables with the help of this data set. Now our objective is, I want suppose total sales corresponding to each category. Now there are several methods to do it. Either you can use filtering, however that's not the appropriate way. You can also use group by. However, in this tutorial, I'll be focusing on pivot tables because pivot table helps you in having a matrix representation, which we'll cover shortly. So for pivot tables, the syntax is df.pivot_table. And then over here, because I am working with sales column, so I'll write with values equals to sales. And because I want the categorization by category column, so I'll write index equals to category. I'll explain about this index equal to in just less than a minute. So by default, pivot table gives you the average of the things. So over here, this table represents average sales by each category. And because I had written index equal to category, that's why each and every single category is represented as one single row. As I mentioned earlier, by default, pivot table gives us the average. So what if I want a total sales, not average sales? So for this, let me copy paste this code over here, and I can use this next command, which is aggfunc. So this aggregate function here, I am writing mean. So then it gives me the average, which is the same as above. However, if I want total sales, I can write sum. And this gives me total sales for each and every single category. Now, what if instead of only category, I also want the total sales corresponding to each category and region combination? So what I can do, I have two options. Either I can have category and region both represented as rows. So I can write something like this. So here I'm giving it a list of columns which I want for categorization, which is give me the total sales for each category and region. And with this, each category and region will be a single row. However, because we are not using group bys, we are using pivot tables. And pivot tables help to represent your data in a matrix format. So what I can do as an alternative way, I can add another parameter. So let me delete this region from here and let me remove this list. So I can have index equal to category and I can have columns equal to region. So what it does, now this represents it in a 2D format. So where every single row is representing a category and every single column is a region. So the way to read it is that the sales for the total sales for furniture in central region is this particular number 163,797. However, if I want the total sales for technology in west, then I'll be looking at the row for technology and I'll be looking at the column west. So the number is 251,991. And we can see this number is exactly same as this number. So both the codes give the same kind of result. However, the output format is different. Now, what if in pivot table, we don't only want sum, but we want multiple characteristics? So what we can do, let me copy paste this code over here. And let's say we not only want sum, but we want sum as well as minimum. Then we are going to write a list in this aggregate function. So over here, my first element of the list is sum, and I can write something like mean, or let's say I can also write minimum. And if I provide this list and I run this code, then notice it is giving me total sales, average sales as well as minimum sales for each category. In the same manner, what we can do that instead of having only sales column here, we can get these aggregations for multiple columns. by giving it as a list. So over here, if I write a list, let's say sales and quantity, and here my index is category, and let me say I have only one aggregation function, which is, let's say, sum. Then it is going to give me total sales and total quantity. That is, this particular aggregate function would be applied to whatever columns which are listed over here in this values parameter. Now in pivot tables there is a one nice thing, that is we can also retrieve the grand totals. So over here, let me write this code. This code gives me the total sales for each and every single category. But if I want to retrieve the grand totals over here, then I will write something called margins equal to true. And when I run this thing, it has returned me a last row, which is all. It means that it is going to give me the total sales for all of the data without any categorization. Similarly, over here, let me just write using this thing that I want total sales and total quantity. And if I write margins equal to true, then notice it is giving me total sales and total quantity, and here it's for the overall data set. Additionally, pivot tables and pandas gives us the flexibility that we can rename this thing. So by default, this total is called ALL, which is all. However, instead of calling it all, I want to give it a custom name. So let's say I want to give it grand total. So I will use the parameter called margins underscore name, and I can write the name whichever I want to give. So I can write grand total over here. And if I run this thing, it's giving me the exact same output as above. However, instead of the by default name for margins, which is all, I am giving it my own customized name, which is grand total. Let's move to our last concept in pivot tables, which is called fill value. So for this, I am using a different data frame where my data frame looks something like this. It contains information about employees from various departments and locations and their corresponding salaries. One thing to note over here that we have got two locations, US and UK. However, only one employee is there from sales department in US. However, there is no employee in the marketing department who belongs to US. This is important because we are going to understand a concept called fill value. So let me create a pivot table over here. What we can see, this pivot table, it firstly takes the salary, it calculates how many employees are there, and then it is calculating the number of employees by each department as well as location. So if I run this thing, we notice that for marketing US, there is a missing value because there is no employee from US who is in the marketing department, right? But what if I don't want to show this NAN? I want to show it 0 or some other default value. Then for this thing, I am using a special parameter which is fill underscore value. This is a default value, that is when a pivot table is seeing some combination which is not having any value at all present in the data, like marketing in US. There is no row present in my data for this thing. Then I can give it a default value in those situations. So if I write now fill value equal to US, then for those special cases, it will give me the value instead of NAN, it will give me 0. So over here, now notice it is returning me 0. Instead of 0, if I would have written some other number, let's say 99999, then it would have given me that particular number. So it's up to me whatever fill value I want to give. So that was all about pivot tables in Pandas. Hope you would have liked this tutorial. Like and comment about how did you find this. Until then, see you soon.